Lepszy. Yep.
Just because that one, it's just the sound is always kind of jumping.
Now, while we manage a few technical things, I will point out to all of you, for anyone who's not aware, Stream 2 is currently running at the same time, and that is on the other side of the venue. You're more than welcome to check out the many interesting presentations there. I'd like to welcome everyone who's watching live on stream. There are people watching us, which is a little bit creepy, but you know, that's okay. And also, I understand our hackers are busy hacking to find a solution. So if you feel like checking out the hackathon, it is just out this door and to the left. Right. Okay, now it's my great pleasure to welcome what I consider one of the most cryptically titled presentations by Alexander Kabirov, Applied Natural Language Processing. I have no idea what this means, so I'm very excited to learn. Alex.
Yep, thanks. So let's test the sound. Okay, hello colleagues. First of all, sorry for my voice. Just got a bit sick, but I believe we'll manage it just right. Let's define the goal of today's meeting. I would like to demonstrate how it is possible to apply natural language processing to solve real-life problems. And before we start, let me ask you a question. So please raise your hand if you're able to process natural language. Alrighty, but honestly, I expected the whole auditorium to raise their hands. It's the machines who have some problem to process natural language. We humans, the pinnacle of creation, if we can read, we can do these simple tasks pretty easily. So the most basic NLP task, the natural language processing task, is called tokenization, or identifying lexical units in a text. In other words, just splitting a text into separate words and punctuation. Next task is also quite simple, lemmatization. It's just transforming a word in its basic form. So from look into look, apple from apple doesn't change. Part of speech tagging. This is pretty simple, so just assign the part of speech tag to each token, so verb, noun, and so on. Next task, next exercise is a bit more complicated. Each token in a sentence has a certain syntactic connection to other tokens. For example, object, subject, proposition, and so on. And dependency parsing is about finding the connection between words or tokens in a sentence. Name entity recognition, very useful thing. So there are often some real-life objects in a text. Like in this example here, Apple is the name of a company or organization. UK is the name of a location, 1 billion is money. So the task of name entity recognition is to identify those real-life objects and mark them with their relevant type. Word embedding. This is a bit more complicated and cutting-edge approach. We humans have no problems understanding what pear or apple does mean, right? We know what's that. But machines, unfortunately, they don't know what those words mean. So what they are doing, what we are able to do, is to define a highly dimensional space. It's about several hundred dimensions usually. And we place words into that space in such a way that words which have a similar context in a large corpus of text are located close to each other. What does it mean? That we can define a vector for apple, define a vector for pear, and then they will be located close to each other because they are similar. Or we can do a very funny thing. We can take a vector for word London, subtract a vector for England, add a vector for France, and get a vector which will be located somewhere close to a vector for Paris, right? Let's go to some more complicated natural processing tasks and some real-life use cases which I have personal experience with. So the sentiment analysis. What sentiment means feelings in English or French, and this is a very good explanation of what is happening here. We are trying to understand the feelings of the person who was writing a text. If a person was happy or upset, and the use case which I was involved in was about routing client requests. So those client requests, when the person was more upset, were processed with a bigger kind of priority, had the tougher SLAs and so on. Next task is the opinion mining. It's somehow related to the sentiment analysis, but here we are identifying an opinion of specific auditorium on a specific subject. For example, on the candidates in the election, or for example, a new product. What we were implementing is how we were analyzing reviews and seeing what people think of the new features of a new product. For example, imagine a phone, Galaxy S7, Samsung Galaxy S7, and the people in the reviews were writing that the display, the screen is good, but the battery is not that nice. So this is about opinion mining. Next thing is the topic modeling. This is an interesting thing. This is an example of unsupervised machine learning, somehow close to clustering. But here we are identifying themes from large corpus of documents and assigning each document to each theme. The use case which I wanted to mention, this is something which I'm working right now. I'm assigned to a project which we are doing exactly the topic modeling. We have a lot of service tickets. We have hundreds of thousands of service tickets. It's not possible to process all of them manually, of course. What we are doing is identifying the large themes from this service tickets. So what was the problems? What were bigger groups of problems? What were bigger groups of resolutions? And how they're connected? And we are able to find insights out of that. So then I have mentioned named entity recognition, but I would like to mention how it can be applied for the OFAC screening process. OFAC screening process is a process defined by US government regulations, and each transaction coming to US bank or from US bank outside of US or from outside to US, it has to be checked if this transaction is not connected to some sanctioned entities. There are a lot of sanctioned entities, for example, in Russia, some organizations which were sanctioned by US government. And if you find a transaction which is sanctioned by US government, we have to block it and report it. There are some systems which they can do this screening, but the problem is that there's a lot of false positives. False positive means that it thought that it's about a sanctioned entity, but it was not. About 70% of all alerts are false positives. So we have implemented a system based on named entity recognition, which allows to significantly reduce the number of these false positives. Another use case, which is applicable for named entity recognition as well, is the negative news screening. So during customer onboarding and during transactions as well, we are trying to see if there is some negative news on a specific person, especially if it's a publicly exposed person. The OCR, this is a well-known concept, stands for optical character recognition. It allows us to get text from an image. And the use case which we're implementing was about processing expenses. If you're traveling, probably have a lot of receipts, right? And your accounting department has some problems processing them. So there's a system to automatically process those expenses and see if there were some unallowed entries in these receipts, like alcohol and so on, and automatically deduct those amounts from the reimbursement amount. The intent extraction. So as far as I know, the next speaker would be about chatbots. So this is a task which would be relevant to them especially. This is about understanding what user wants. For example, if user is typing or saying, please turn up the heating by 5 degrees, we should understand that we have to call the function change temperature, and the parameters are turn it up and by 5 degrees. So this is useful conversation interfaces. We're implementing some chatbots. We were using this technique for such applications. So before we come to the questions, I want to do a small demo, actually two. Let's start from here. Unfortunately, we have very limited amount of time, so don't have enough time. Oh, what's wrong? It's not visible what I have here. What's wrong?
We have technical issue and no technician.
Yes.
There's no
So,
projection on the display.
someone maybe
and
could
no
help me
technician at the
to
moment,
see what's happening
unless
here.
it's come back. Thank you. So how many financial technical people does it take to fix one projector?
Awesome. So don't
Three.
get scared. But what you see now. Unfortunately, we don't have enough time to show a proper demo of one of the products which we have. So I decided to create specifically for this presentation a showcase what you can do in a few lines of code if you know what you're doing. So this is a naive implementation of the sentiment analysis. It's naive, but it still uses some of the cutting edge things as the mentioned word embedding, right? So what we do here is we obtain the word vectors for words bad and good, and then we compare each word in a sentence to both words, and if it's significantly closer to any of those extremes, then we consider it either positive or negative word. If it's somewhere in the middle, then it's a neutral one. Let's take a look if it works. Yes. Okay, the sentence is positive, obviously, because it's great. Negative, but I told it is pretty naive, and I will show why. Because if I'll write well, so you can see here that I'm typing I'm not feeling well, and it will recognize it as a positive because it found the positive word well, but it didn't see that there is a negation not. So we can add one more line here. This is it, and where we can check that in our dependency tree there are no negations for this specific token, and if there is, we revert the sign from 1 to -1 and so on. If it's 0, it's neutral, then it's not get affected. So let's try if it works. So you can see now it is recognized as negative. So it works. So this is just a very small example of what you can do in a few lines to recognize the sentiment on the sentence in the current case. So we have still a few minutes. So let's go with those. So I didn't get any questions here. So yeah, please. Mm-hmm. 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 So this is very interesting topic. So this implementation which I showed, this is pretty naive. It doesn't take into account such things, but we could plug in some. Probably, if you're doing this application for some specific market, for example, for US market, we can teach the system to recognize specific types of kind of common sayings, common constructions which have an opposite meaning in this specific language. What I was doing, I was creating an ontology. So ontology is a kind of structure of something which represents our subject, the topic. And I was using ontologies to kind of incorporate this type of exceptions to revert the sentiment kind of direction if this falls into this exception field.
Okay. We seem to have the questions up on Slido.
Awesome. So if it can different cultures, so this is something which I was answering right now. So we could obviously we can take this into account, but this it would be a bit more complicated implementation. It will take a bit more than 5 lines of code, but it's possible. Obviously, it's possible to create the kind of software with open libraries only. Yes. For example, for the demonstration which I have demonstrated, this is a state-of-the-art library in natural language processing called Spacey, the fastest and the most precise. So, and this is open source, and most of the tools which you will ever need, like GenSim for topic modeling and so on, they're all open source. So we can go with that. Colleagues, unfortunately, I will have to leave soon after this presentation. So if you have any questions, please, any more questions, please reach out to my email or call me if you wish. Yeah, so I think time is up.
Thank you, Alex. But if you can't call him, send him an email with a mix of sentences. He can analyze it, see if it's positive, negative, and decide if he wants to reply to you. So, that's a negative email. I'm going to put that in my archive folder. Yes. Check later. Thank you very much. Our next guest will be, I think, building on a very similar topic.